Good morning, Tamina Khan is here in TKMaths is fun. In today's video, we will see question number 1 to question number 6 for May-June 2024, variant 1-2. So I have solved the question here. I will go through the important points only and you will see the solution, and you can pause the video where you need more explanation. So here the coefficient of x square in the expansion of 1 minus 4x power 6 is 12 times the coefficient of x square in the expansion of 2 plus ax power 5. So this will be the form of the equation. You will find the coefficient of x square here. You will find the coefficient of x square here, and you will form this equation. Right? I'm calling it coefficient 1 and calling it coefficient 2. So you can see here I have found it by the simple formula, the coefficient of x square, and which is 96 here. And in the second binomial, there is unknown a. So I got 160 a square. Sorry. And okay. So I form an equation and I got a is equals to root 3 upon 5. It was written here the value of positive constant a. So that's why I'm taking here plus root 3 upon 5. Okay. If you find any calculation mistake, you can mention it in the comments. Now question number 2. The curve y is equals to x square is transformed to the curve y is equals to 4 times x minus 3 square minus 8. You have to describe fully a sequence of transformation. So 5 marks. Distribution of marks we'll see in the marking scheme. So if you see here, there are 3 things happening. When it is inside the bracket x minus 3, it means it is transformed to the right by 3 units. Then it is 4. I'm doing stepwise here. You can say step 1, 2, 3. So it is a stretch along y-axis by the scale factor 4. And then in the end minus 8. So there is a vertical shift of 8 unit downward. So we know here the transformation functions, the order it is followed, exactly the one which I have told you, right? Reflection is not part in this question. Otherwise, reflection comes before vertical shift. Now let's see question number 3, which is show that the equation 7 tan theta divided by cos theta plus 12 equals to 0. And you have to express this into this form. So it's an easy question. So you can see step here. I have just substitute tan theta by sin theta over cos theta, and after that algebraic manipulation type. And then here I have identity, applied identity. Did I? Yes, I did. Cos squared theta is 1 minus sin squared theta, right? So now next part of the question is saying solve it. You can see here. So in place of this, I will write down this expansion which I have gotten because it's a quadratic equation. I mean the quadratic form, right? So after that, I will factorize it. And this one we all know is not possible. So we will write rejected or not possible. And for the other one, we will solve it by the using ASTC method. You know that, right? So let's come to question number 4. The function f is defined as follow. Find an expression for f inverse x. So you can see here the simple method, put the function equals to y and make x a subject. And after that, replace x by y and y by x. So I hope there is no confusion in it. It's a straightforward question. Then part 2. Here if you see fx is given for the domain x greater than 1. Now in this question, the diagram shows the graph of y is equals to g of x. Now if you see here, this curve equation is same. No, that was the part 2. Sorry, I'm mixing up 2 things. So anyway, so g of x is given to you 1 divided by x square plus 2 for x belongs to real number, and you can see the shape of the curve here. You have to find the range of g. Range of g mean values of y, right? To make the question easy, the what it is called sketch is here for you. So you can see the highest point is this, and the lowest point will be this 0, which it will never be touched. So it will be your asymptote basically, because every time we will plug in the value of x, it is 1 divided by something, right? And as you increase the value of x, the denominator keep increasing, and overall this keep decreasing. So that's why value will always be more than 0. So that's why you will write the range, because this is my range. The range is greater than 0, but what is this value? How will you get it? Simply put x equals to 0 in it, right? So when you will put x0 here, 0 square is 0 plus 2, half. So that's why this will become your range. Can you notice I have not put equals to symbol here, right? Because it will never touch 0. So these are the little things which you will always take care. Now let's go to the part C. Part C I have solved by two methods, because students think differently. So I have solved here by both methods so that you can connect or expand your knowledge. The function h of x is defined by this. The same was the function g, but there the domain was given to you real number, right? But now it is saying x greater than 0. It means this side of the graph, okay, which I have highlighted with the red color. So this is the equation we have to solve. H of f of x is equals to f of 25 over 16. Now function f was given to you in part 1. I am simply substituting 25 upon 16 in it, and I got here, if you see here, I am getting here 5 minus 4, 1 upon 4. So basically the answer of this part is equals to 1 over 4 that I have figured out, and I am writing it on this side. If you see later on, it is 1 over 4. Okay. Now the left hand side, which is h of f of x, is a composite function. So one method is that you substitute the function f of x, which is this, in h. And where is h? Here. So in this place you substitute here. This is exactly what I have done here, you can see. And then you simplify the equation. I'm expanding it by algebraic method a minus b whole square. And after that I did cross multiply here. And then I solved the equation. This will take the form of the disguised quadratic equation. And I solved here. I got the two values of t. But our target is to find the value of x, because question is saying solve the equation here in part C. So we have to find the value of x, right? Let me just erase this a bit. So once you get the value of t, okay, so after that you will plug it back in the substitution you have taken here. So I'm substituting it back here, and I got here, you see here, this one, if you see here, I'm further simplifying it. You will have a calculator. The steps I am showing just to explain it to you, but otherwise using the calculator you will get immediately these answers, so your time can be saved. So now these two values of t I will substitute back in the substitution which I have taken initially to get the value of x. So left hand side, if you see first, it's fine, and I'm getting x value 3 plus 2 root 2. Now don't forget here that your inside function is h of f of x, and the domain of x was given to you greater than or equal to 1, or just greater than 1. Just a minute, greater than 1. Okay, so the value of x was given to you here is greater than 1. Okay, so now when I solved here by this method, I got 3 plus 2 root 2, which is greater than 1. But when I try from this side, I got value less than 1, so I will reject. So this is not my answer. Why did I write immediately here? Because at a glance I can see here at this stage, if I write here root x minus 1 is equals to minus root 2. So it is wrong, because if you will take any value of x greater than 1, you can never get the answer negative. So I immediately got the idea here, it should be rejected. But I kept showing you that how will you ensure? I mean, if you're not understanding, then how can you go till last? Anyway, second method is, in the first method, we saw that f of 25 over 26, not 26, sorry, 16, is 1 over 4, right? And instead of h of f of x, now I'm applying the concept of inverse on both sides. So what it will become? It will become this thing. You know that concept. This concept was applied in March 24 paper as well, right? If you remember, I made the video on that also. The same concept was applied there. So after doing this, now I will find the inverse function of h of h. I will plug in 1 over 4 in it, and I will replace the function f of x and solve the equation. So let's see here. This second method is shorter also, right? So h of x was given to you 1 over x square plus 2. All of you know how to find the inverse function. The same method. The only thing is that you have to decide that in the last you will use the plus sign or minus sign along, because the domain of a for h of x is the range of h inverse x, because this is your which function h inverse x. So the range of this is actually the domain of h, and the domain of h was what? It was x greater than equals to 0. So this should be the range of inverse function, and that's why I will consider only plus value. Now once I have found h inverse x, going back here, this one, now I will substitute 1 over 4 in it. Okay, so just a minute. So in the inverse function of h, now I will substitute 1 over 4. Here I have substituted and I got root 2. So this was the equation, right? This is what we have found there. So now on the right hand side I will write root 2 here, and left hand side f of x, I'm writing the function. You can see here, and I'm solving it, and I got this answer. So this is how I will solve that equation. Now come number 5. This is related to series. So this was only that here they have given trigonometric function. So the first term is tan theta and the second term is sin theta. It is arithmetic progression. So I have written here a plus d second term, or a is the first term. To find the difference, what do? We subtract the two terms. So my difference is sin theta minus tan theta. And after that he is saying find the sum of the 40 terms in the progression. So I'm simply applying the formula, substituting values and expanding it. And question is saying theta is pi by 4. So I'm plugging in that value in it. And I got the answer minus 740 plus 390 root 2. Question was saying give the exact answer, so that's why you will leave it like this. Okay. And what you will remember here, mode of the calculator should be what? Radian, absolutely. Right. So mode of the calculator you have to select carefully. Okay. Then second part of the same question is find the sum to infinity of the progression in terms of theta. Now this time the same terms tan theta and sin theta are considered as geometric progression, first and second term. So here again I have written the general geometric progression. This is your term 1 and this is your term 2. And for r, what do? Divide second term, divide by first term. So here I am dividing it on the right hand side to show you. If you see this side, I will end up at r equals to cos theta. Right? I have to find the sum of infinity. The formula is here. So I am substituting the values and I got this answer. Okay. Given that theta, now part 2, theta equals to pi by 3, find the sum of the first 10 terms in the progression. Give your answer correct to 3 significant figure. So it is talking about the same part here. Same part, it has b1, b2. So now you are applying the formula for the sum of the finite terms, a 1 minus r power n, 1 minus r. And I'm substituting the value, doing nothing else, using the calculator, and I got the answer in 3 significant figure, 3.56. Right. And I'm sure you know when you write cos or any trigonometric function, if you have power n here, it is actually equals to this thing, right? So when I'm writing here, do not understand, rather I should make here brackets so that nobody get confused. It is power 10 here outside, right? It is not on the theta actually. Sixth question, which is related to, it is very vague, I took the pictures only, somebody sent the pictures. The curve for the equation is given and it is saying that the minimum point is at A and intersect the curve at x-axis, positive x-axis at B. So this is given to you. You have to find the coordinates of A and B. So you know that for the minimum and maximum point, you always differentiate the equation and put it equals to 0. So this is what I have done on the left hand side. And I got the value of x4 and I got this point. And similarly for B, I have done what? I have put y equals to 0 because the information or the hint is that it is passing through the positive x-axis. So y coordinate will be 0. So I'm putting y coordinate 0 in the equation of the curve and solving it. So I got x16, x0. So this is my point B. So I got my point B and point A, part 1. Now part 2 is saying the diagram is giving and you have to find the area of the shaded region. So we have just found in part 1 the x coordinate of A is 4 and the x coordinate of B is 16. So my limits will be what? 4 to 16, right? This is 4. So limits are 4 to 15. Achha, by the way, if somebody by mistake without realizing that A and B have been found in first term, so what he will do, he will solve them simultaneously and find the value of 16 and point A and point B. But try not to do this because you already know the points. So now we know when we are finding out the area between the curve and the line or between two curves, we always do upper curve minus lower curve and take the limits. So exactly the same thing. Exactly the same thing I'm doing here. 2x minus 32 upon 3. So I'm considering this as my upper curve and this as my lower curve. Okay. And I am applying it. The formula upper curve minus lower curve and simplifying it. You can see here I simplified it. Then I'm simplifying because once I will apply integration, this symbol should have gone from here, right? Like in this step, you can see there is no more this integral symbol. So I have integrated it and I have applied limit. Because calculator is allowed, I would recommend that up till this line you do show what are you substituting, and then you can use calculator to get the answer. So area is coming 32 upon 3. So the next question is equation of a circle, but video has gotten longer. So that from 7 to 11 or 10 questions I will solve in video number 2. I hope you understood it. Thank you very much for watching. Share it with your friends and wait for my next video. Take care. Allah Hafiz. Do subscribe so that you get the bell icon, bell ring when I will upload my second video. Take care. Allah Hafiz.